¿Ya está grabando? So we have an amusement park ride that consists of a rotating circular platform that is 7.34 meters in diameter, from which a 10-kilogram seats are suspended at the end of a 2.18 meter massless chain. The system rotates. The chains make an angle of 21.1 degrees with the vertical. The acceleration is 9.8 meters per second. So they want us to find the speed. So the way that we're gonna set up this problem is before we start setting up, let's actually draw a picture because you guys have that. So there's this thing, we know the diameter of that is 7.34. So 7.34 divided by 2 gives me a radius of 3.67. We have a chain. It has an L. And we have a theta here of 21.1. You tell me the length is 2.18. So I want to set up this problem. Centripetal force is equal to mass times centripetal acceleration, v squared over r. And I know this thing has a mass of 10 kilograms. So we need to find out what is the centripetal force. Because we know we're going to be able to find the radius, we know the mass, we need to find what the centripetal force is. So what is the thing that's causing it to spin? It's the tension. The tension is going to be the centripetal force. But I care about the forces that are pointing towards the center. So this force, this tension, is at an angle. So I need to split it up into its vertical and horizontal. So I have this right here, and then I have the vertical. So I'm splitting up this force into, this side is going to be, here's my angle, so this is opposite. So T sine of the angle, and this is adjacent next to, so this is T cosine of the angle. So I only care about the forces that are pointing towards the center. The forces that point towards the center, that's the centripetal force. This force is at an angle. Usually, last time when I was doing it like this, it was not at an angle, so it was just tension. But with the centripetal force, I care about the forces that point towards the middle of the circle. So this is the force that points, this thing's going this way. I care about the force that points towards the middle, and that's this force of tension, the sine of the angle. So I know that T sine of the angle is going to equal to M v squared over r. So I'm going to plug in the things I know. I don't know the tension, they don't give me that in the problem. But I know the angle is 21.1. I know the mass is 10. I'm looking for the velocity, and I can calculate the radius by doing some other math right here. So this right here is the radius. So the radius is going to be this part plus this part. So how am I going to get this part right here? It's going to be this length right here. If I know the diagonal of this triangle, I can find this part right here. So I know that here's my triangle, and this is 2.18. This is 21.1. So I have sine of 21.1 equals opposite over hypotenuse 2.18. So then I move that down here. 2.18 sine of 21 equals theta. Sorry, not theta. Equals that right there. Lx. So let's see what that gives me. 21.2.8 2.18 2.18 times sine of 21.1 gives me 0.784. So this thing has a length Lx of 0.784 plus some of this right here, some of this circle going on right there. So I care about the rate, this other radius right here, which I already calculated was 3.67. So I take the radius of the center circle plus this part of the rope, the horizontal part of the rope, plus 3.7. So my radius is 4.45479 if I want to use all numbers. So how did I get that radius? It was the horizontal length of the rope plus the radius of the center circle. That's how I got that R. So if I want to solve for V, I still need to know what that tension is. What is that tension of the rope? So going back to, because that's getting a little bit messy. I know there's tension right here. I know that this is T cosine of the angle. And I know that this is T sine of the angle. And I know that this is mg. And they told me that this was 10, this was 9.8. So I know that these forces must be balanced. My T cosine of the angle must be equal to mg. T cosine of, and they told me this was 21.1. T 21.1 is going to equal to 98. So let's see what that tension is. 98 divided by cosine of 21.1 trig cosine of 21.1. My tension is equal to 105.043. So I'm going to plug in that number over here. That's my tension. So 105.043 105.043. And then I do some algebra here. So I'm going to multiply all these together. 105.043 times sine of 21.1. That gives me 37.8151 equals 10 v squared over 4.45479. I'm going to divide by 10 on both sides because these are being multiplied. So once I divide by 10, I get 3.78151 equals 4.454. So then I'm going to multiply because this is being divided. So I'm going to multiply by both sides. So I get times 4.45479. I get 16.8459. And I'm going to take the square root of that. I get the square root of that, and my velocity ends up being, my velocity is going to end up being 4. Sorry, it's got a little bit messy, so I want to erase this. I almost said delete. So once I multiply there, 4.45, multiply the same thing over here, I got 16.8459 equals v squared. Take the square root, and 4.10437 equals my velocity. So let's look at what we did. The big thing is this T sine of the angle towards the middle, that's your centripetal force. That's going to be equal to mv squared over r. Your radius is going to come from this triangle right here, which is the length, the horizontal length, plus that radius of the center. That's going to be the radius of the whole circle. And then this tension we saw from this free body diagram, where T cosine of the angle is equal to your mg. T cosine of the angle is going to equal to your mg, so we can solve for this tension that goes right there. And that's how you solve number 11. Number 12, once you do 11, number 12 becomes a lot simpler. So if a child of mass 51 kilograms sits on the seat, what is the tension of the chain at the same angle? So they want to know the tension. So we don't need to know all this anymore. We just need to know this relationship over here. So we have tension, and then the angle right here, 21.1 in my case. And then the upward part is, here's tension. The horizontal part is t sine of the angle because it's horizontal, sorry, because it's opposite. And then adjacent, we have t cosine of the angle. Downward, we have mg. And the reason we split tension up is because it's at an angle. So I know that t cosine of the angle must be equal to mg. I know my angle is going to be 21.1. And my mass is going to be the mass of the seat plus the mass of the person, sorry, the child, which is 51.2 times 9.8. So even if you don't do number 12, you should be able, sorry, even if you don't do number 11, you should be able to do number 12 because this is just this over here. So this becomes 61.2 times 9.8. 61.2 times 9.8. And that gives me 599.76. T cosine of the angle 21.1. T cosine of the angle 21.1. So I want tension by itself, so I'm going to divide both sides by cosine of 21.1 and this side by cosine of 21.1. So that divided by cosine of 21.1 gives me 642. My tension is going to be equal to 642.86 newtons. So thanks for watching. Get your quest done. Don't quit.